Continuing the walkthrough of the explain-ash output, now we come to this section here, which is called the activity class summary and activity summary, which is in principle just an aggregation of the type of activity that you see in the active session history relating to this SQL execution. So either you see that the activity is on CPU or it is related to some wait class. The activity class summary is about the so-called wait classes. So you see things like user IO, application, or configuration information here, whereas the same information is then aggregated by the corresponding wait event information. Again, either on CPU, so not waiting, actually actively working on CPU, or waiting for some wait event, like in this case here, this user IO activity, direct path read, write temp, or single block reads, like this here. And you get here also the information about how many samples correspond to each entry and the percentage, along with some graphical representation here, so that you get an easy overview. This is more or less the same, so there is no difference between a parallel and a serial execution analysis. So as you see here, the same information for serial execution. And again, you see the activity class and activity summary, so there is no difference between serial and parallel execution. There is, however, a difference if we look at a cross-instance parallel execution analysis. Then actually there is each section comes twice. Once is here a global aggregation, which is across all instances, so that basically corresponds to what you see for the single instance report. So you get here the same heading, so the same activity class summary you get for the cross instance execution as well, but in case of cross instance you get another section here, which is specific to cross-instance parallel execution, which you won't find on single instance executions. You get the same information then broken down per instance, which gives you some clues about the way the activity was distributed or spread across the different nodes. So in this case here, if you remember from the previous tutorials, I deliberately made this an uneven distribution, so one node had to work more than the other node simply due to the fact that it's a two-node cluster, and I requested a parallel degree of 3, so some of the one node had to work more than the other node, and this is also reflected here in this information. So instance number 1 has more activity shown here than instance number 2. So that is the same information here, just again broken down on instance ID. And the same is then repeated for the activity summary on wait event level. Again, you get the global summary and you get then the summary per instance. This is then the same again, just repeated and then broken down by instance ID. There is another another specialty of this section here. If you use this so-called experimental mode of explain-ash, then you get additional information, which then looks like this here. This is for each of these wait events or wait classes. You get average and middle values, average and middle values, minimum and maximum values. The reason why this is not shown by default is simply that you have to be very careful with that kind of information, because this is what is sometimes called bad active session history math. You shouldn't apply averages and things like that to sampled data. So this is misleading because sampling means that you basically put the emphasis on longer wait events, which means that these averages here are not the true averages, because the sampled wait events are those that take longer. So this is definitely always a average and middle value that is greater than the actual average and middle value. So that's the reason why I don't show this information by default, because it can be very misleading. The reason why I offer the option to show this via this experimental mode is that sometimes it might make sense. If you know what you're doing and you know that you have to be very careful with these values, then maybe you're able to tell something from these averages and maximum values. For example, if you would expect something like physical I/O to take between 5 or 10 milliseconds, and you would see something averages like 500 milliseconds or maybe more than a second, then maybe this could be an indication that something was broken, like a hardware or software defect that led to such bad average wait times. But again, as I said, you have to be very, very careful with that. So that's the reason why it's only shown if you explicitly request this information via this experimental flag that you can enter at the prompt or at the command line. So that's additional information that you can request, and maybe in a future version I plan to incorporate a specific formula that then tries to actually calculate the closer approximation of the true averages. There is an information. There is a formula available that might be able to do that. So maybe if I find some time, I will test this formula and maybe then incorporate it. Then this information here might be more useful than it is at present. So this part here, these averages and middle values, minimum maximum values, will only be shown if you enable this experimental mode. This information here, this activity class, here and activity summary, in principle, to give you some more orientation, corresponds to what you get from the real-time signal monitoring here. In particular in 12C, you get this activity here. So this is basically the same information. You see here, this is also based on samples and gives you an idea how many samples were on CPU, how many were on user I/O. You do not have this separation here between wait classes and wait events. So this is on wait events, and this is a different data source. So this is here database time measured actually, whereas this is based on active session history here. So this activity here, this basically corresponds to what I show here in the report. Now, in this particular case here, if you wonder why because it's about the same execution, why these two do not correspond to each other, because you see here that the report shows 193 samples on CPU, 67%, whereas Xplan-Ash here shows on CPU just 132 samples and 71%. How is it possible that these two, using the same data source, come to different results? Well, this is just a bug in the real-time signal monitoring. If you have such a execution plan here, a parallel execution plan that includes multiple so-called DFO trees, and this is one here with this temp table transformation. We have one DFO tree for this temp table transformation, and then a second DFO tree for the part that accesses then the temp table. In this case here, the real-time signal monitoring does some double accounting. Real-time signal monitoring doesn't really cope very well with the fact that such an execution plan actually ends up with multiple child cursors. So this DFO tree here is executed with a different child cursor than this part here, and therefore there is some double accounting taking place. You can see this also here from this activity tab. At the parallel degree of 3, you probably won't be able to reach an activity level of 8 active sessions at any point in time, and we can also see this here, that we do not actually see here an sample point where we see an activity of 8 active sessions. So this is one of the points where real-time signal monitoring is, in my opinion, incorrect, and the Explain-Ash output is correct. So yes, so this is just to give you an idea. This is this activity information here, which corresponds to the sections here, this activity class and activity summary.